Okay, now let us look at this. How do we use the second derivative test for the local mean and local max? So we use the second derivative test for the concave up and down, but now we want to use the second derivative test for the local max and local mean. These are the rules. First, find out the f prime of x and critical numbers. Find the first derivative and find out where the first derivative is 0 or undefined. Then find out the second derivative and all the critical numbers. Suppose here the critical numbers are c1, c2, c3 and so on. And what you do is, after you find out the second derivative, you plug in each of the critical numbers in the second derivative and look at the sign. If the second derivative is positive, then local mean, because second derivative positive means concave up, right? Concave up means there is a local mean. If the second derivative is negative, it is concave down. That means this figure will look like this, concave down. So there is a local max, right? When you plug in that C1 or C2 or C3, whatever, and when you plug in, if you get the second derivative positive, then there is a local mean. If the second derivative is negative, local max. If the second derivative is equals to 0, then undecided, we will not know what will be that. Will that be local max, local mean, or point of inflection? Because the second derivative equals to 0 does not imply the point of inflection directly. We'll have to do the more work for that. Ci may be point of inflection or not. We need to use the first derivative test to on left and right of Ci. We'll have to check whether it is increasing, decreasing, decreasing, increasing, what is happening there, and we will decide from that. Okay, let us do an example. So we want to find out the we want to use the second derivative test to find out the local max and local mean. So let's follow this step. What is f prime? It is 4x cubed minus 24x squared plus 0, right? So now we need to find out critical points. Since there is no x in the denominator or the root, so it is defined everywhere. So we don't have to worry about where the function first derivative is not defined for the critical point. So what we do is you set that equals to 0. What do you get? When you set that equals 0, let me take 4x square out. What is left is x minus 6 is left, right? So if you set 4x square equals to 0, what do you get? X equals to 0. And if you set x minus 6 equals to 0, what do you get? X equals to 6. These are the two critical points, right? Critical numbers. After you find out the critical numbers, find out the second derivative. What is f double prime? You find out the derivative of this one, right? That is 12x squared minus 48x, right? So what do you do with that? Let us plug in 0. So at x equals to 0, what is f double prime? Oh, f double prime is 0. So it is undecided case, right? So we'll have to go with the first derivative. Or you can use the second derivative for the concave up and down, or use the first derivative. Either one, you will get the answer. Okay. So we'll have to do more work for this one. So let's do at x equals to 6. What do you get? 12 times 6 square is how much? 12 times 36 minus 48 times 6. Let me use calculator for that. So 12 times 36 minus 48 times 6 is 156. That will be positive. F double prime will be 156. That is positive. So positive, f double prime positive means what? Local mean, right? So f has local mean at x equals to 6. Now we need to do more work for the x equals to 0, right? Because we were undecided. Let me write undecided. Let's work more. Okay. So at x equals to 0, f double prime is 0. But how about the first derivative on the left and right of x equals to 0? This is 0 here. 0. I want to take a test point. Let's say negative 1 and then positive 1. At negative 1, what happens? We are taking the first derivative, right? What is the first derivative? It is 4x cubed minus 24x squared. 4x cubed minus 24x squared. First derivative will give you increasing and decreasing pattern, and then in that way you will be able to find out. Okay. So on the left of 0, if you plug in negative 1, what do you get? 4 times negative 1 to the cube is negative 4 minus 24 times negative 1 square will be positive 1. So negative 4 minus 24 will be negative. So this will be negative, meaning it is decreasing. And if we plug in 1, 4 times 1 to the cube is 4, minus 24 times 1 square is minus 20. 4 minus 24, it is also negative. So it is also decreasing. You see that? There is no local max or local mean there, because it is decreasing and then decreasing again. Looks like the graph look like at 0, the graph look like this. Decreasing and then decreasing again, and but see, left of 0 is concave up, right of 0 is concave down. Maybe like that. So x equals to 0 is basically the point of inflection. Okay, so x equals to 0 has no max and no mean, but it has point of inflection. It has point of inflection because it is decreasing on both sides of that, and the second derivative is 0 there, right? So it is the boundary between the concave up and concave down. So basically it is the point of inflection there. Okay, I mean, you can check the second derivative too. In this, if you do the second derivative, you will see, for example, left and right of 0. Let's check the second derivative too, right? Just to make sure. 0. So what is f double prime? I want to find the sign of f double prime there on the left and right of 0. On the left of 0, let me take the test point as negative 1. On the right of 0, positive 1 again. If I plug in the second derivative, negative 1. If I plug in negative 1 here, what do you get? 12 times negative 1 square is positive, minus 48 times negative 1 is positive. So positive will be, this is positive, right? On the right, it will be 12 minus 48 if you plug in 1. 12 minus 48 will be negative. So the right side is, see, it is concave up on the left side and down on the right side. So it is basically the point of inflection. Okay, so it doesn't have local max, only the local mean, right? So let me write down the final answer. Relative mean at x equals to 6, point of inflection at x equals to 0. That is the final answer. We will do a couple more examples. Okay, let us look at this example similar to the previous one, but it has a fraction in the exponent. Okay, so first we need to find out the critical numbers, right? What is f prime? It's 8 over 9 x to the 8 over 9 minus 1 minus 0. So that will be 8 over 9 x to the, what is 8 over 9 minus 1? That will be negative 1/9, right? So if you write that, it will be 8 over 9 x to the 1/9. That's what I get. Okay, so to find out the critical numbers, what we do? We find out where the function is not defined or where the function is 0. This function is not 0 anywhere, right? But it is not defined if x is 0. So f prime is not defined at x equals to 0. So the critical number is x equals to 0. That's the critical number, right? Now let's find out the second derivative. To find out the second derivative, you can pick this step, right? This one, because it is in the x to the n form. So it will be 8 over 9 times negative 1/9 times x to the negative 1/9 plus 1, right? So if you do that, what do you get? Negative 8 over 81 times x to the, oh, by the way, this is minus 1, not plus 1. This is minus 1. Okay, so x to the negative 1/9 minus 1 will be negative 10/9. If you simplify this, you will get negative 8 over 81 times x to the 10/9. Okay, 9 there. So what I do is at x equals to 0, f double prime is undefined, right? In case of the, if it was positive, we would say minimum. If it was negative, we would say maximum. In that case, what we do is we do the first derivative test. Use first derivative. We will find out the increasing and decreasing thing. First derivative test, or you can use the second derivative test too, it doesn't matter. Okay, you will get positive and negative, and they will say concave up, concave down. In that way you will be able to find out. So let's do that first derivative test. So the point that we are interested is 0. Okay, so we'll take a test point on the left of 0 and right of 0, -1, +1. So if you plug in -1, what do you get? If you plug in -1 here, right? So -1 to the 10. I mean, we'll plug in the first derivative, right? First, let me write down first derivative. So if you do that, what do you get? So first derivative is 8 over 9 times x to the 1/9, right? If you plug in 1, +1 and -1, what do you get? 9 over x, x to the -1 to the 9th, right? That will give you the negative sign, negative, 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 negative. And if you plug in +1 for x, you will get positive sign, positive, 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 positive. So what you can say, it is decreasing and it is increasing there, right? Since there is decreasing and increasing, you can say that there is a relative minimum, right? So x equals to 0. F has, so let me write, F has a relative or local minimum at x equals to 0. Why? Because on the left of 0 it is decreasing, on the right of 0 it is increasing. I mean, you can do that. The second derivative test also. Second derivative test would give you both of them will be concave downward. Both side it will be negative, so it will be concave downward, meaning that there is chance of local minimum. Okay. All right. Let us do another example. Find relative max or relative mean for this function. Again, do the same step. Find out the first derivative. What is the first derivative? F prime is negative sine x minus 8, right? And set that equals to 0, or find out where it is not defined, because we need to find out the critical numbers, right? So if you do that, what do you get? Set that equals to 0, you will get negative sine x minus 8 equals to 0. So negative sine x equals to 8. I added 8 on both sides. So what is sine x? Is negative 8, right? So what is x? Will be arc sine negative 8. Oh, this is not true, because this is false, right? Because sine cannot be negative 8. Sine will be between -1 and +1. So it is not possible to happen. So what we get is there is no critical points or the critical number. No critical numbers. No critical number means there is no max or mean, because if there is a max and mean, max or mean, local max or local mean, it must be on the critical number. If there is no critical number, then there is no local max and mean. And in fact, this is negative everywhere, right? You see that? Because the sine x value will be between -1 and +1. So the minimum value of the sine x is -1. In that case, it will -1 times negative will be +1. Minus 8 will be. So it is always decreasing. In fact, f prime is less than 0 for all x. That means f is decreasing everywhere. Decreasing everywhere. You see that? So the function fx is decreasing everywhere there. Okay, or non-increasing, I would say, everywhere. So there is no maxima minima, no extrema, we say. Because for both maxima and minima, we use the word extrema, right? So let us do last example for this section. If fx is ax cubed plus bx squared plus cx plus d, okay, and then what is given, and the first is f of x has a local maxima at 3, local minima at 5, okay, and then also what is given is point of inflection is at 4, 0. So what we want to do is we want to find out A, B, C, and D. Let us do it. So what is given is at 3, 11, meaning f of 3 equals to 11. F of 5 equals to 9. This is basically x, this is y, right? So x and y. Also, what is given? Since it is local max at 3, then you need to have f prime of 3 must be 0. And it has local mean, meaning f prime of 5 must be 0 as well. You see that? What is the next? It is the point of inflection at 4. What does that mean? That means f of 4 is, oh, by the way, let me write down here, f of 4 equals to 10, and then f double prime of 4 is equals to 0. We are assuming here that all the derivative defined everywhere, okay? All the derivative are defined everywhere, okay? Now let us plug in that f3 equals to 11 implies what? Plug in x equals to 3 and fx equals to 11. You will get 11 equals to 27a plus 9b plus 3c plus d. That's what you get. And f5 equals to 9 implies 9 equals to 125a plus 25b plus 5. See, I'm just plugging in x equals to 5, right? And then plus d. That's what I get. So what is f prime? This is, let's say this is equation 1. This is equation 2. Okay. So let us subtract 2 from 1. Subtract. Subtract means all of them will be minus, 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 minus. So what do you get? You will get 2 equals to negative 98a, right? Minus 16b minus twice c, and that will cancel out, right? So basically you get this equation, right? Or if you want to, you can multiply by both sides by negative 1, and then you will get 98a plus 16b plus 2c equals to negative 2. Let's say this is equation 3. Now, I want to use, you can use f4 equals to 10 and then do that way. You can do either way. There are so many ways you can do that. So let's find out f prime of 3. What is f prime of 3? F prime of x. First find out f prime of x, and then we will create equation with that. What is f prime of x? Is basically 3ax square plus 2bx plus c, right? And I want to plug in f prime of 3 equals to 0. So 0 equals to 27a plus 6b plus c, right? Let's say this is equation 4. And then another f prime of 5 is equals to also 0. So 0 equals to, you will get, so what do you get? So 27a plus 6b plus c is for f prime of 3. F prime of 5 will be 25 plus 75a, right? Plus 10b plus c. And then you subtract those again. Subtract, 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 subtract. What do you get? You cancel out that, right? 75 minus 27 will be how much? Is that 48a? 48a minus, right? Equals to 0 is there. And then minus 4b. You see that? So what do you get? If you simplify that, you will get basically, let me divide by negative 4. What do you get? 0 equals to, you get 12a plus b, equation number, this is equation 5, and this is equation number 6. Now we are getting closer, right? Now what we want to do next is, I want to use that information, okay? F double prime of 4 equals to 0. What is f double prime? I'm running out of space, but let me find out f double prime. F double prime is, you'll get c out, right? So that will be 6ax plus 2b. and then use that f double prime 4 equals to 0. What do you get? F double prime of 4 equals to 0 implies 0 equals to 24a plus 2b. Basically, you get exactly the same equation there. So you will get basically 12a plus b. So basically, you don't have to do that because we got the same equation. You don't have to do this part, okay? You can solve equation 3 and 4. You see that? Equation 3 has 98a plus 16b plus twice c minus 2 equals to -2, and that has 27a plus 6b plus c. So what I want to do next is basically solve it. So let me list equation 3. Equation 3 is, what do you get in equation 3? Is 49a, because if you divide both sides by 2, you will get 49a plus 8b plus c equals -1, and equation 4. Let me write equation 4. Right? So how does it look like? Equation 4 is 27a plus 6b plus c equals to 0, right? If you subtract these two equations, subtract, what do you get? Subtract. You cancel out those, right? Equals to -1 is there. 8b minus 2b is 6b is 2b plus, and 49 minus 27 is how much? Is that 22? 22a. Let us name this as equation number 7. Now we will solve equation 6 and 7, okay? So what is equation 6? Let me write down equation 6. Oops. So let me write down equation 6. Equation 6 is 12a plus b. 12a plus b equals to 0. If you solve these two, how do you solve these two? You need to multiply the second by -2, right? You need to multiply by -2. And if you solve that, you will get that -2 and 2 will cancel out, right? 2b, and because it will be -24a and then minus 2b equals to 0. That's what you will get if you multiply, right? And then you will cancel out those two. What do you get? You get negative twice a equals to -1. So a is basically 1/2. So you need to plug in a equals to 1/2 into number 6. Use equation 6. What do you get? So 12a plus b equals to 0. A is 1/2. 12 times 1/2 plus b equals to 0. So what do you get? So this is 6, right? So b equals to -6 you will get, because 12 divided by 2 is that. So now you will plug in a and b in equation number, let me see which equation, number 4 or number 3. Use equation 3. What do you get? So in equation 3 you got 98 times a is 1/2, right? Plus 16 times b is -6, and then plus c, twice c, right, equals to -2. So if you simplify this, you will get c equals to 45/2, and you use the equation, you use the value of a, b and c in use equation number 1 to find out d, right? So if you use that, you will get d equals to -16. You will get d equals to -16. Okay, well, how do you find out that? You will get 11 equals to 27 times 1/2 plus 9 times -6 plus 3 times 45/2, right? And then plus d. And if you use calculator, you will get d equals to -16. This is what you get. So we got the value of all a, b, c, and d. Okay. Thank you guys. So this is the end of this section.